This is the beginning of Unit 4, Derivative Rules, and this is Keeper 4.1, the power rule. This is the power rule. This is your definition or your formula. D over dx, that means that you're taking the derivative with respect to x, with that being in the denominator, of x to some power. And it equals n times x to the n minus 1. So these are the steps that you'll take for the power rule. First, you're going to rewrite the expression in the form of x to an exponent. So if you had a radical, you would need to rewrite it. If you had your exponent and your x in the denominator, you need to move it to the numerator. Then you perform the power rule, which is you take the exponent, you bring it to the front, you multiply, and then your new exponent is one number less than what the original was. And you're going to simplify your answer. Sometimes you're going to get an answer like 4x to the negative 3. Do not leave answers with negative exponents. You would change that to 4 over x cubed. Okay, find the derivative and simplify. We're going to have 9 examples in your keeper. Number 1, y equals the cube root of x plus the 5th root of x. Okay, we don't have this written as a power, so you can't apply the power rule yet. So your first step is going to be rewriting. Rewrite as y equals x to the 1/3 plus x to the 1/5. The next step is now you can apply the derivative rule for powers. You're going to take your exponent 1/3, multiply it to the front, and then subtract 1 from your exponent. So it's 1/3 x to the 1/3 minus 1, and plus 1/5 x to the 1/5 minus 1. Y prime means that you've taken the derivative, so you'll change y to y prime. The derivative of y equals 1/3 x to the negative 2/3, that's what you get after subtracting 1, plus 1/5 x to the negative 4/5. Don't leave negative exponents. You need to move the x with these negative exponents to the denominators. So your last step is to simplify your answer. Number 2, y equals 1 over x squared. We can't apply the power rule because your power is in the denominator. So you need to move the x squared to the numerator first. So we're going to rewrite. And that makes it y equals x to the negative 2. Now, you don't need to keep writing rewrite, power rule, simplify every time, but you need to have these steps shown. Now we're going to apply the power rule. Bring your negative 2 to the front and subtract 1 from negative 2. So you will get y prime equals negative 2 x to the negative 3. Don't leave that negative exponent. The negative exponent only goes with the x. So we're going to move the x to the negative 3 to the denominator and make it a positive exponent. And the derivative of y equals negative 2 over x cubed. Here's number 3. Y equals 5 over 2x cubed. So this is similar to number 2 in that you have your x to the 3rd in the denominator. You're going to move the x to the numerator, but the 2 does not move with it because it's not in parentheses. So first step, rewrite. Y equals 5 over 2 x to the negative 3. So if you rewrote it and you have 5x cubed over 2, you want to pull the coefficients out to the front, the 5/2, and then it's 5/2 times the x to the negative 3. Now we're going to apply the power rule. So you're multiplying negative 3 to 5/2, and then subtract 1 from the negative 3. So y prime equals, and we have the 5/2 there, and the negative 3 x to the negative 4 is the derivative. It's the power rule of the x to the negative 3, and so you can now multiply those together. So when you bring the negative 3 to the front as part of the power rule, it will eventually get multiplied with the 5/2. And so you simplify your answer. And the derivative of y equals negative 15 over 2x to the 4th. Here is example number 4. Y equals 1 over 2 times the cube root of x. So we need to rewrite the cube root of x as a rational exponent, x to the 1/3, but it's also in the denominator. So you're going to pull this 1/2 out to the front and then rewrite the cube root of x that's in the denominator as x to the negative 1/3 in the numerator. We can now apply the power rule. So you still have the 1/2 that's being multiplied, but apply the power rule to the x to the negative 1/3, and it'll be negative 1/3 x, and then subtract 1, and you get negative 4/3 for your new exponent. And then finally simplify by multiplying 1/2 times negative 1/3 to result in negative 1/6. And then move your x to the negative 4/3 to the denominator, making it x to the positive 4/3. You can leave your answers with rational exponents like you have here, or you could rewrite it as a radical, negative 1 over 6 times the cube root of x to the 4th. Number 5, y equals 7 over 3 x to the negative 2. So first, move the 7/3 to the front, and then you would be left with like 1 over x to the negative 2. You're going to rewrite that by calling it x squared in the numerator. We can now apply the power rule. So 7/3, and then times 2x, and 2 minus 1 is 1. And lastly, simplify. 7/3 times 2 is 14/3 x, and you do not need to write to the first power. Number 6. Okay, now we have to use, well, first we're going to change the square root of x to a rational exponent, which you know is x to the 1/2. And then you can't apply the power rule when you have an x in the numerator and the denominator, so we're going to use our exponent rules. So we have the y equals x to the 1/2 over x. Properties of exponents, so you're going to subtract x to the 1/2 minus 1. And that's x to the negative 1/2. Now that it's in that power form, you can apply the power rule. Multiply the negative 1/2 to the front, subtract 1 from your exponent. We have negative 1x to the negative 3/2. It's a negative exponent. We're not going to leave that there. We're going to move the x to the negative 3/2 to the denominator with the 2. So y prime equals negative 1 over 2x to the 3/2. Number 7. All right, so we definitely need to simplify this problem. You're going to start by distributing 3x to x squared minus 2x. 3x times x squared, you know, is 3x cubed, and 3x times negative 2 over x would be negative 6x over x. So that's why I have negative 6. Now apply the power rule. You have two terms here. You have the 3x cubed and the minus 6. So you're applying the power rule to each of these. 3x cubed, bring the 3 to the front. You're going to multiply. That's 9x squared. And then you have the minus 6, which is 6x to the 0. So if I apply the power rule to a constant, it's 0 times negative 6 is 0, and then you have 0 times x. So the derivative of a constant is 0. And then we simplify. 3 times 3x squared the derivative of y equals 9x squared. Number 8, we cannot apply the rule yet, so you are going to divide each, well, when you have a rational expression and you have a monomial in the denominator, like this x squared, we are going to divide each term in the numerator by that monomial in the denominator. So x cubed divided by x squared, minus negative 3x squared over x squared, and 4 over x squared. And when you do that, like I've got x cubed divided by x squared is x. Negative 3x squared over x squared is just negative 3. And 4 over x squared, I'm going to move the x squared to the numerator, and that's what makes it x to the negative 2. So the power rule, the derivative of x is 1. So let me add this in here. We know that the understood exponent is 1. Oops. So it kind of looked like a 4. Hang on. So it's a 1 there. So you do 1 times x, and 1 is your exponent, minus 1 is x to the 0. So you would have 1 and then x to the 0. X to the 0 is 1, and that's how you get 1 times 1. This didn't quite fit all on one line, but it's 4 times, and then the negative 2 goes to the front, subtract 1 from your exponent. So that's just like the other ones. And then we'll simplify by moving the x to the negative 3 to the denominator. 4 times negative 2 is just on a separate line, makes this the negative 8. So the derivative of y equals 1 minus 8 over x cubed. And this is our last example. Number 9, t of c, so c is our variable here, equals 4c squared minus 7c plus 3. Find dt of dc when c equals 2. So that means find the derivative of function t with respect to c when c equals 2. So first we're going to find the derivative, and once you have the derivative, we can evaluate when c equals 2. So we don't need to rewrite. There's nothing to do here. So it's the same as the problem. We're going to apply the power rule. So now you should be pretty quick at this. You can look at 4c squared and now multiplying by 2, subtracting 1, so that's 8c. Negative 7c, when it's to the first, you end up with just a constant, so negative c. And then the derivative of a constant is going to be 0. So using the power rule, you have that the derivative of t, of c with respect to c, equals 8c minus 7. So now we're asked to find it when c is 2, so you can take c and plug it into this derivative for c. So 8 times 2 minus 7 is 16 minus 7, which equals 9. And I believe that is our last example.